Hi guys, good afternoon everyone. Yes, good afternoon guys. How are you everyone? So I hope everyone is doing well. And today we are going to talk about electrolytic cell. We'll be also learning how to represent any of the electrochemical cell and many of the things we'll be learning about it. Yes, so let's just start with this topic. But before that, all those learners who are new to the platform, so yes, all those learners who are new to the platform, they must be curious, they must be willing to know about me, so know about their chemistry educator. So talking about myself, I am Manisha and I am chemistry educator at Unacademy. I have enriched 5 years of experience at reputed online and offline institutes, and I have done masters from NIT Warangal and bachelor's degree I have, yes, done from the Delhi University. I have cracked IIT jams, CSAR, NET and GATE. Yes, and I have given best ranks to my students. I have given a good number of selections in NEET and AIMS. And yes, I'm a plus verified tutor, guys. So this is what is about me. Now talking about few of the things regarding the classes, guys. So where you can get the information regarding the classes. So you can get the information regarding the classes on our Telegram group, and on the Telegram group, how will be getting the information? So you have to, yes, you have to join our Telegram group by using the link which is there here, or you can use the barcode over here to scan and join the group directly. So that is there. Now let me give you a special information about our special classes. So guys, what are the special things about the special classes are? You can learn from your favorite educators for free. You can engage with the educators via polls. You can clear your doubts live in live special classes. So yes, that are there. Talking about the live special class timetable. So 19 July, guys, we did a topic named hyperconjugation and aromaticity, which many of the students they have doubt. Then after that, we will be having today a session on a special session on geometrical isomerism, and 28 July will be learning about optical isomerism. So special classes are the classes, guys, which are just like the classes which happens on YouTube. So they are absolutely free and you can join them and learn about all these topics. Now talking about what are the good things about Unacademy subscription features. So the first thing is you can learn live from the comfort of your home. You don't have to step out anywhere. You don't have to waste the time in that. Yes, that you can do. Then other than that, you have unlimited access to all the courses. You'll be learning from the top educators of India. You will be having a regular doubt clearing sessions. We'll be doing the exhaustive coverage of syllabus. There will be a complete mentorship and guidance throughout. You'll be getting all the study material in the PDF formats. Yes, you'll be getting practice tests, live test series, batch courses, like everything, whatnot. So it's a bundle of package which is going to give you so many things, and that too in a very affordable prices. And Unacademy is celebrating the achievers of ISC Class 10, guys, who have achieved a really good score, and I hope all of you guys who are studying here, they also will be getting a really good score. So guys, here I'm introducing you to a very special offer and a very good offer, that already the prices of Unacademy, they are very affordable. Yes, but if you will be, yes, if you will be taking the subscription till 29 July, good afternoon Veena, how are you? So if you'll be taking the subscription till 29 July, yes, what you have to know, you will be getting instant 20% discount. What you'll be getting, guys? You'll be getting instant 20% discount. So for that, what you have to do, you have to use my code, which is MRIS10, and you'll be getting instant 20% discount, guys. Very good. So this we have understood. Now let me give you information about the ongoing batches which are going right now for ISC Class 12. The batch started on July 6th, and who and all are taking classes over there. So I'm taking chemistry, and we have all the, yes, all the amazing teachers for biology, physics and maths. So we have that. And talking about for ISC Class 11, the batch which is going on right now is Brahmastra batch. Yes, that is for ISC Class 11. So make sure you are enrolling for it. So if you are an ISC Class 11 student, you are going to get the Class 12 subscription absolutely free. So that is actually a very good offer. So everyone should make sure you are taking advantage of this offer, and yes, you are enrolling for our plus course classes. Very good, guys. So let's just start with the topic without wasting the time. So what we are going to discuss is, we'll be discussing about representation of electrochemical cell. What we'll be learning, guys? We'll be learning about representation of electrochemical cells. So how you can do, so whether it is a electrolytic cell or it is galvanic cell, so how you can do the representation of it, let's just understand that. So to learn how to do the representation of electrochemical cell, what you have to do, guys, you have to know ABCD. Yes? Okay, you must be thinking that ABCD? How? So guys, you know that ABC in the order, right? So everyone knows that this, no one can forget ABCD, yes? So what A stands in ABC? So A stands for, yes, anode. B stands for bridge, if it is there, and then C stands for cathode. So always how you will be mentioning any of the electrochemical cells, so it's very simple, guys. You have to remember ABC. A is anode, B is bridge, C is cathode. Now how we can mention anode? Yes, like let's just understand that as well. So anode, what reaction occurs, guys? Yes, oxidation occurs at anode, everyone. So like suppose you have a metal, yes, it will be losing electrons and will get some positive charge. So how you will do the representation of anode? So representation of anode you can do is very simple. I'll be mentioning it. You mention very easily the M, right? You'll be mentioning then Mn positive. What you'll be doing, guys, you'll be mentioning first the metal and then you'll be mentioning the ion by putting a slash over there. Yes, very good. Now how we do the representation of cathode? So you know that cathode, in cathode what happens? The gain of electron happens. So if I talk about what we can relate, so cathode, what happens is your Mn positive will be gaining the electron and will give you M, right? So whatever is there on the left hand side, you write that first and then you write on the right hand side, means whatever is the reactant you write that first and then you write product. So here in the cathode case, what I'll be writing, how I'll be mentioning Mn positive and M. This is how I am going to represent it. So Mn positive and M, like that I'll be mentioning. Now how you represent bridge, guys? Yes, how you do the representation of bridge? So representation of bridge is done. So bridge representation is done how? By showing a double slash. The parallel lines also you can relate. So by using two parallel lines, what you can do, guys, you can represent the bridge. So you have to use two parallel lines. Like now for example, suppose you have to represent any cell, like talking about the galvanic cell. So if you have to represent the galvanic cell, how you will do that? Tell me everyone. Yes, how you will be doing the representation of galvanic cell? It's very simple. The galvanic cell net reaction we know Zn plus Cu2 positive gives Zn2 positive plus Cu. So what is my anode? Anode is nothing but zinc because it is getting oxidized. What is my cathode, guys? Cathode is nothing but, again, what we can relate, it is, yes, it is your copper. So because it is undergoing reduction, so we can relate this is oxidation and this is reduction. So oxidation occurs at anode and reduction occurs at cathode. So how you will be representing it, guys? It's very simple. I told you the trick. You have to remember A, B, C. So what is A? Anode. Anode is, yes, oxidation always occurs at anode. So what I can mention? I can mention Zn, Zn2 positive first, right? Then double slash salt bridge, and I'll be mentioning what? Cu2 positive and Cu. Clear with it, guys? So this is the representation of galvanic cell. This is the representation of galvanic cell. Remember that in this you can mention, yes, so in the representation, in the cell representation only, what we can do, we can mention the concentration, we can mention the, yes, we can mention the concentration, we can also mention the state of the substance. Like what they can do, they can mention zinc solid, right, slash Zn2 positive. If you know the concentration, suppose you are taking 1 molar, so that you can mention as a sub in the subscript, correct? Then slash, you can mention Cu2 positive, say its concentration is also 1 molar. Then what you can mention Cu, which is also solid, because Cu is a metal, so obviously it is going to be solid, and that's what we can understand. Correct, guys? So Cu is metal, and what we can relate, it's also going to be solid. So this is what we have got to know, which is nothing but, yes, it can be mentioned. So in cell representation, concentration of the substance, as well as concentration, as well as what, guys, the state can be mentioned in the subscript. Clear with it, guys? Yes, tell me, everyone. So if I'll be giving you a reaction, say you have Mg plus 2Ag plus gives, yes, Mg2 positive plus 2Ag. So all of you, can you write the cell representation for it? Yes, everyone should try to write the cell representation for it. Yes, everyone. So everyone should try to write the cell representation for the particular given reaction. So let's see who and all will be able to write it. Tell me, guys. So again, I'm reminding you the trick, which is nothing but ABC. Anode, bridge, cathode. For bridge, we mention double slash, or you can mention parallel lines, 2 parallel lines. So I'll be mentioning, so anode is Mg2 Mg2 positive, so I will mention Mg Mg2 positive. Then I will mention slash, yes, 2Ag plus and 2Ag, like that will be mentioning, which is nothing but the cell representation of the particular given thing. Clear with it, everyone? Yes. Tell me, guys, everyone understood? So what we'll be doing now, guys, we'll be learning little bit more about the electrolytic cell. So when we discussed about the electrochemical cells, we learned that there are 2 types of electrochemical cell. One is your galvanic cell, another is your electrolytic cell. So little bit things we'll be learning about electrolytic cell, so that you'll be having good information, and then we can relate. So what is electrolytic cell, guys? Yes, so electrolytic cell is nothing but, it is the cell Yes, what is electrolytic cell, guys? So it is the cell in which electrolysis takes place. Yes, so the cell or the device in which electrolysis takes place is called as electrolytic cell. Yes, very good. So the device or the apparatus used for electrolysis is called electrolytic cell. The device or apparatus used for, yes, electrolysis is called what, guys? For electrolysis is called electrolytic cell. Correct? Very good. Now what is electrolysis? So we'll be learning even about Faraday's law of electrolysis and everything. But can anyone answer that? What is electrolysis? Tell me, guys. Anyone knows what is electrolysis? Yeah. So always remember, whenever this lysis or lysis, like whatever, if this comes in any name, so this means lysis means breaking. So electrolysis means breaking of something in the presence of electricity. If I hope everyone is able to relate. So what is electrolysis? Electrolysis is coming from the lysis, which is breaking. So what is electrolysis? We can write the process of decomposition of. What is that, guys? The process of decomposition of. The process of decomposition of an electrolyte into. So the process of decomposition of an electrolyte of an electrolyte into what, guys? Into ions, into its ions by passing obviously what, guys? By passing electricity through its molten or aqueous, through its molten or aqueous state, that we know is known as the process of decomposition of an electrolyte into ions by passing electricity through its molten or aqueous state, is known as electrolysis. Correct, guys? So if you have any electrolyte, we have learned in the previous classes what is electrolyte. You must have learned that even in your lower classes also, guys. Electrolyte is nothing but it is a chemical substance which dissociate into ions and conducts electricity in its aqueous or molten state. Very good. So how it dissociates, guys? So it dissociates with the help of electricity. Correct. It decomposes with the help of electricity, and that's what we can understand. Very good. So we got to know what is electrolysis. Now let's just little bit discuss about the electrolytic cell, how it looks like, how the device looks like. So the first thing, in electrolytic cell there is only one compartment. Always remember, in electrolytic cell there is only one compartment, and both of your electrodes, they are present in the single compartment only, whether it is anode or it is cathode. Yes. Now what we can relate, both the anodes and cathodes, obviously they'll be connected to a battery. Yes, they'll be connected to a battery, so that also we can relate. So in the electrolytic cell, first thing that we have to know, that we have both the electrodes in the same compartment, in the same cell. You will be having both the electrodes. So you have here anode and cathode. What is the charge on anode and what is the charge on cathode, guys? Yes, tell me, what is the charge on anode and what is the charge on cathode? So anode is positively charged. Yes, while cathode is negatively charged. Anode is positively charged while cathode is negatively charged. Correct? Very good. So this we can understand. So anode is positive, cathode is negative. Now what you will be having? You will be having a electrolyte over here. What you will be having? You will be having some electrolyte. Now what electrolyte you take? So obviously depending upon what substance or what reaction you want. So you'll be taking any of the electrolyte. What is this? This is your electrolyte only. Yes, guys. So you'll be taking electrolyte over here. What you'll be taking? You'll be taking, so I have to choose a pen. So we'll be taking electrolyte over here. Very good. So anode is positive and cathode is negative. So whatever electrolyte you will take, it is going to have anions, guys. Here, like ions, it is going to have anions and cations. So it is going to have both of them. So what we can relate here, that whatever, right, anions will be having, they'll be moving towards the anode, while whatever cations will be having, they'll be moving towards the cathode. So basically it's very simple, guys. Whatever your anions will be there, they will go and get attached on the anode, and the cations, they will go and start getting accumulated on the cathode. Correct, guys? So your anions get accumulated at anode and cations get accumulated at cathode. But what happens to it after going over there, after getting accumulated over there? So that we have to learn. So it's very simple, guys. What you have to know, on passing electricity, yes, on passing electricity, what happens, guys? From obviously from where you have to pass electricity, through molten or aqueous state, of electrolyte. So on passing electricity through molten or aqueous state of electrolyte, yes, what happens? It dissociates into ions. It dissociates into ions, and after it will get dissociated into ions, tell me everyone. Yes, Veena, everyone. So dissociates into what? Yes, it dissociates into ions and migrate and migrate towards the oppositely charged electrodes, and migrates towards the oppositely charged electrodes. Oppositely charged electrodes, guys. Yes, and when they'll be reaching to the oppositely charged electrodes, so what we can relate, so after reaching their respective electrodes, they get neutralized, because if a negative charge thing will go to the positive charge thing, so what you can relate, it is going to get neutralized. So that's what we can relate. So the ions then migrate towards the oppositely charged electrodes, and after that what you can relate, after reaching there, yes, what we have to know, after reaching there, yes, the ions, or what you have to know, after reaching their respective electrodes, they get neutralized. So after reaching their respective electrodes, they get neutralized. They get neutralized. Very good. So this is what we have got to know. Yes, that what is there in the electrolytic cell. So first of all, there is only one compartment. There are no two compartments. So no salt bridge is required. What do you have to know? No salt bridge is required over here. Okay, because if you'll be requiring a salt bridge, for what? For what purpose you will be requiring? You will be requiring it to connect two half cells. Yes, two half cells internally, but there is only one cell itself. So why it is required for you to connect, right? Why it is required? So it's not required. So that's what we can understand. Very good. Now let's just take an example for, right? So for example, yes, what we'll be discussing, for example, NaCl. Yes, so if we take the NaCl in the molten form, can anyone tell what is the meaning of NaCl in molten state? Yes. Can anyone tell what is the meaning of NaCl in molten state? It's very simple. You are just melting it. What you took your common salt, you took the sodium chloride and you just melted it. And once you melted it, what you will get a liquid form of it, a molten form of it. Now, if you take that as electrolyte, so what you will be getting at anode and what you will be getting at cathode, guys? Tell me. So at anode, what you have to know is very simple. Your at anode, anions goes. So your chloride ions, yes, your two chloride ions will be losing, yes, the electrons and will become 2Cl plus 2 electron. You can write, and obviously 2Cl will be combining together and it will be forming Cl2. Correct, guys? So 2Cl negative, they'll be losing, because what happens at anode? Tell me everyone, at anode what happens? It changes due to the difference in the cell. What say everyone? No, right? It doesn't changes. So always remember, yeah, always remember, the electrons always are lost at anode, means oxidation always occurs at anode. So 2Cl minus, what they'll be doing? They'll be losing 2 electrons and you will be getting what? 2Cl combining, because obviously the single atom of chlorine is unstable. Very okay. Good, Siddhartha. That's the chloralkali process which you are telling. Very good, Siddhartha. So what you can relate here, you will be getting Cl2. So basically what we are doing, Siddhartha, we are learning not about the chloralkali process, we are learning about the electrolysis of molten NaCl. So what happens when we do the electrolysis of molten NaCl? So obviously in chloralkali process also we take a brine solution and we do the electrolysis of it, and that's what we get. So this is what we'll be getting. So I'm not taking, but you take their aqueous. But here I'm talking about molten, Siddhartha, right? Molten means there is no water. I have just taken the sodium chloride and I have melted it. What you are saying, the reaction, it will be more appropriate for the aqueous sodium chloride. Okay? Clear with it, Siddhartha? I hope you understood. And at cathode, what will be happening? Your 2Na plus, they will be gaining 2 electron and will be giving you 2 sodium atom. Yes, so what do you get at anode? At anode, you will be getting chlorine gas. And at cathode, what you will be getting? You will be getting the sodium atom or sodium element or sodium metal, anything you can say. So what you can relate, if I'm be doing the electrolysis of NaCl, which I'm taking molten, what I'll be getting at anode, I'll be getting at anode chlorine, and at cathode what I'll be getting, very simple, nothing but sodium. Correct? Very good. Now what we have to know next, suppose if I say I take NaCl aqueous, yes, so this I hope everyone will be able to relate. Now if I'm taking the NaCl aqueous as an example, so NaCl aqueous means you have NaCl plus water together, right? Now here the reaction will be occurring on the basis of preferential, yes, preferential adsorption on the, yes, your anode and cathode, so preferential accumulation. So basically at anode, you know that anions comes near it. So what you have in NaCl there will be two ions, Na plus and Cl minus ion. But when you will be passing the electricity, you won't say, no, okay, electricity, you go and just break NaCl, right? No, you can't guide electricity to just like go and break only this compound or not the other compound which is present. Obviously when you will be supplying the electricity, yes, it will be breaking whatever substance present in that. So NaCl will break in Na plus and Cl minus, while water breaks in H plus and OH minus ion, correct? But if I talk about what will be getting at anode and what will be getting at cathode, so all of you must have learned in 10th standard chlor-alkali process. You remember what used to get in the anode or what used to get in the cathode? Tell me guys. Yes, tell me everyone. Veena, Siddharth, yes, everyone. What say it is going to be? What reaction? So it's very simple guys. What will be getting at anode and at cathode? So at anode, yes, you get the reaction of OH minus ion. So basically you have a Cl minus ion and you have, yes, you have Cl minus ion, you have also the OH minus ion. But instead of Cl minus ion, you will be having the OH minus ions which will be coming and getting accumulated at anode. So your OH minus ions guys, what they do, so your OH minus ion, they, yes, loses the electron, right? And what they form water plus oxygen gas. So they gives water plus oxygen gas. Very good. No, you will be getting at anode here oxygen. So that used to be there in the chlor-alkali process, correct, right? But here if I talk about at anode, if I'll be taking NaCl aqueous, and that too we are not taking the concentrated form of it. So what you will be getting? Yes, you will be getting the, yeah. So if you will take concentrated sodium chloride, no Siddhartha, then you are going to get. But if I'm taking normal aqueous NaCl and then I'm doing the reaction, so what I'm going to do? At anode I will get OH minus ion will get converted into water and O2. And what will be the reaction for it? So you will have 4 OH minus ions aqueous. They'll be giving 2 water molecules plus O2 and they'll be losing 4 electron. And at cathode, what will happen? Very simple. At cathode, yes, you'll be having the hydrogen and sodium. Yeah. So what you can relate? Yes, it's very simple guys. What you can relate is that if you have a sodium here and you have a hydrogen here, 2 positive ions are there. So remember that you can talk about the electrolysis on the basis of 2 things. You can have a sodium chloride dilute versus concentrated. So you can take NaCl dilute also, and you can take NaCl concentrated also. Getting my point guys? You can take NaCl dilute also, and you can say take what? You can take NaCl concentrated also. So NaCl dilute means what? You are taking less amount of sodium chloride and dissolving in water, right? So you are having water and sodium chloride. But if I'm saying NaCl concentrated, so you are taking more amount of sodium chloride over there, and that's how you are getting the product. Correct. So if I talk about what you will be getting when you will be taking the dilute form, yes, we'll be taking the dilute form of it. So it's very simple. You will be getting at cathode, instead of sodium, you will be getting hydrogen. So what reaction occurs over there, Siddhartha? You will be having the 4H plus ions, they will be gaining 4 electrons and they will be giving you 2H2 gas. So this is what occurs when you take the dilute NaCl. Okay, what you will be getting? You will be getting the dilute NaCl, you will be getting that. But if you will be taking the saturated or the concentrated, so if you take the saturated or concentrated, yes, if you take the saturated or concentrated NaCl, which we used to take, hello Harshit. So if you'll be taking saturated or concentrated NaCl, what products you are going to get? So you are going to get different. Yes. So it's very simple. You will be getting the product as chlorine and H2 gas. So you, instead of oxygen gas, you will be getting chlorine and hydrogen gas. So at anode, yes, what you will get? At anode, you will get the hydrogen gas. Yes. Tell me guys, hydrogen gas or chlorine gas? No, you will be getting chlorine gas at anode. Yes, Siddhartha, able to relate? Harshit? So at anode, you will get a chlorine gas instead of the oxygen gas. If you are taking it the concentrated, so you will get chlorine gas. And at cathode, what you will get, guys? Yes, at cathode, you will be getting, very good. So saturated or concentrated NaCl means brine solution if you will take. So you will get at cathode, what? You will be getting at cathode hydrogen gas. Clear with it, guys? So this is going to be the difference regarding the electrolysis. So what we understood, what is electrolysis? Siddhartha, Harshit, everyone. Electrolysis is nothing but it is the, yes, it is the decomposition of a, yes, the decomposition of an electrolyte into its ions by passing electricity through its molten or aqueous state. Remember that why your electrolyte dissociates into ions? It's very simple. You can relate, no, like in movies and all we see, the whenever like someone wants to take out the truth from a terrorist or some person, so they apply them electric shock. Why? Because electric shock is very powerful. Correct. Same way, if you will be passing electricity to a solution, what is going to happen? The bonds, whatever are there between the ions, they are going to break and you are going to get the ions. Now, the ions that we get, yes, the ions that we get, obviously what you have to relate, they are going to go, like the ions that we get from the electrolyte, so they are going to go to the oppositely charged electrodes and they are going to get accumulated over there. And once they get accumulated over there, what you have to know, that they will be, yes, they will be getting neutralized, and that's what we can relate. So saturated or concentrated HCl, what you will be getting, the difference, that's what we have understood. I hope everyone is clear. Harshit, Siddhartha, tell me, any doubt, anyone? Yes? Everyone understood? Very good. So now we'll be learning few of the things here, that is Faraday's law of electrolysis. What we'll be learning is, we'll be learning about Faraday's law of electrolysis. So we learned what is electrolysis, and now we'll be learning that there was a scientist named Faraday who gave the law of electrolysis. Okay, and what is that? Yes, what is that? Let's just understand that. So Faraday's law of electrolysis, what it says, guys, it says like first of all, there are two laws which was given by Faraday. So there are two laws. So Faraday's law of electrolysis, there are two laws over here, guys. What and all are that? So there is a first law, and what it says, yes, so he said, I have a doubt on passing electricity. Siddhartha said one thing, that on passing electricity through sodium chloride solution breaks down into sodium chloride, sodium positive and chloride. Then why compound does not lose its property when it's breakdown? Because what happens, you know, see here what is happening when you are adding sodium chloride, right, and what you are doing is that you are passing electricity to a sodium chloride solution. So obviously it breaks into ion, Na plus and Cl minus ion. So what is happening over here? This Na plus and Cl minus ion, they can combine with the other things, no? Are you getting that, Siddhartha? So basically they are losing the properties, they are losing the characteristics. That's why you get NaOH plus hydrogen plus chlorine, no? You're getting the different products, and that's what you used to learn in the chloralkali process. Are you getting that? So basically this Na plus and Cl minus ion, what they are going to do, they are going to combine with the different stuff and they will be forming the product. Like Na plus combines with the OH minus and it will be giving you NaOH. Then you, along with that, hydrogen atoms combine together give you hydrogen gas. Chlorine atoms combine together and give you chlorine gas. So that's what you get the products, no? So NaCl, obviously till what time the electrolysis will be keep on taking place, till the time all the NaCl molecules won't get converted into NaOH, H2 and Cl2. Getting this point, Siddhartha? Yes, I hope I'm able to clear what you have asked, or maybe your question is not that clear. You basically asking on passing electricity through sodium chloride solution, it breaks down into Na plus and Cl minus. Obviously, then why compound does not lose its property when it's breakdown? So, if suppose you are having NaCl only, okay, what do you have if you have only NaCl molten? So what you can relate, there is nothing else to combine together. Are you getting my point? So why it won't lose its identity? Because there is nothing else to combine. So they will, if suppose they have to combine, they will be only combining with the themselves, and they'll be forming NaCl only. But when you are taking aqueous solution, what you have to know, and that there will be water also, with whose ions it can combine and it can lose its identity and form a new substance. Got that, Siddhartha? Clear with it? Yeah? Tell me, guys. Okay, so let's just discuss about the law of electrolysis. If you have still any doubt or anything which is like, say, clicking your mind that okay, why not this or why this, so that also you can ask in the chat. We'll be discussing about it. So the first law, guys, the first law of Faraday, what it says, it says nothing but the amount of, yes, the amount of different substances. What it says, the amount of different substances, yes, the amount of different substances produced at any electrode, different substances produced at any electrode, yes guys, is directly proportional to, so the amount of different substances produced at any electrode during electrolysis, by a current, right, by a current is directly proportional, is directly proportional, is directly proportional to what, guys? To the quantity of electricity, proportional to the quantity of electricity passed through the electrolytic solution. Passed through the electrolytic solution, guys. Passed through the electrolytic solution. Okay, very good. Passed through the electrolytic solution. So Faraday's first law, what it says, Siddhartha, everyone, Harshit, that is nothing but the amount of different substances produced at any electrode during electrolysis by current is directly proportional to the quantity of electricity passed through the electrolytic solution. So what we can understand from here, we can give a small expression that W, the weight generated, is going to be directly proportional to Q. Yes, what is W here? Where W is the weight of substance produced, is nothing but weight of substance produced or generated. Yes, and Q is the charge. What is Q, guys? Q is the charge. Correct. What is I? Like you can relate that Q is equal to I into T, current into time. So what is I? I is equal to current and T is equal to time. Clear with it, guys? So if I know that charge is equal to current into time, can I use that? So I can write W is directly proportional to IT also I can write. Now whenever till the time there will be a proportionality sign, I want to be, ma'am, when we put hydrochloric acid in water, then it will be ionized to form H plus and Cl minus bonds breakdown. And why does HCl not lose its properties on dissolving in water? Because what you can relate, it's here, basically you're not accumulating those ions and just isolating it, Siddhartha. Are you getting my point? When I'm doing the electrolysis, what I'm doing is I am having the electrodes where those ions will get accumulated and that can be isolated and can be obtained But when you're just taking HCl and water, there is nothing where you can accumulate. So the ions, they rearrange and combine with themselves only and stays the same. Are you getting my point? Yes, Siddhartha. So you are saying when we put hydrochloric acid in water, then it will ionize to form H plus and Cl minus. Bonds break down, then why does HCl not lose its properties on dissolving in water? So it's very simple, Siddhartha. Like here, when I'm adding, say you have here. So you have a water here, right? H2. When you're doing HCl to it, so HCl when you're adding, so water is not dissociating into ions. Are you getting that? Here water is not dissociating into ions. Water is just the way it is. And HCl is going to dissociate into ions, which is H plus and Cl minus. So when it will dissociate into ions, they will stay just like that only, because there is no one else, other ion to combine with them. So how they are going to lose their characteristics? They will stay the same. Are you getting this point? Siddhartha, yes. Suppose tell me, okay, like you can relate with a very simple thing. Say you go to your classroom and you have your best friends, right? You have your good friends, not best friends. You have your good friends in the class itself, right? Now when you will go to the class, every day those friends only are there. So can you make a new friend? No. Until unless new students are coming in the class or you are going to some new school, you cannot make the new friends. No, you cannot make the new bond. Getting that point? Yes, Siddhartha. So basically when you're adding just water in the water, like HCl in the water, HCl will dissociate into ions because it's a strong electrolyte, but water will remain just the way it is. But when you do the electrolysis, even water also breaks into ions, and that's why you get the different products. Clear with it, Siddhartha? Now it is clear? Okay. So what I was discussing, no, why it is remaining as acid? You're not getting that, Siddhartha. See, you're having the water, right? The moment you're putting in the water, hydrogen and chlorine will dissociate into ions. But do they have something else? No. They will combine with themselves only and again will form HCl, because they will get attracted. No, say they dissociate into ions, but they are still ions, no, oppositely charged. So they'll be attracting each other and they'll be attracting each other. What you can relate? Yes, they will again combine. No, so you'll be having many of the molecules. They'll be again combining it. So what happens? It's still dissociated into ions. That ions are there, but still they will be bounded with each other with that attraction. H plus and Cl minus will be feeling that attraction. So this is still remains as an acid only. Getting this? Because you have a water, H plus and Cl minus ion, obviously you will be having the aqueous forms of these ions, but they are oppositely charged. They will get attracted to each other. So that's why it still remains an acid. Like I can give you one example, because there is no other ion. Suppose if you add NaOH and HCl, you are having NaOH plus HCl. So NaOH plus HCl, when you will add, they both will dissociate into ions, Na plus and OH minus ion, H plus and Cl minus ion. Now why they give NaCl plus water here? Because they have other ions with which they can combine. So you have Na plus can combine with Cl minus, oppositely charged, and it gives you NaCl. OH minus can combine with H plus and can give you water. Getting that, Siddhartha? So that's why you get the different products. But here in HCl there is no other ion with which it can break, so it still remains as HCl only. Okay? Yeah? Okay, I hope you got the clarity about it. Now understood? Very good. Right? It's just very simple, because they have some other ions, they combine and they lose the characteristics, and that's why the reaction occurs. NaH plus HCl gives NaCl plus water, because they interchange their ions. But here, if I tell again, there is only possibilities, the same ions only, H plus and Cl minus ion only. They are not going to combine with anything, so they have just this thing only that combine with themselves only, and it doesn't lose the characteristics. So that's what we can understand. Very good. So what we were learning is about the Faraday's law of electrolysis. What Faraday's law of electrolysis says, Siddhartha, it says that the amount of different substances produced at any electron during electrolysis by current is directly proportional to, yes, the quantity of electricity passed through the electrolytic solution. So obviously how much electricity you are going to pass, that much weight of a substance is going to get generated. Why? Because that much your electrolyte is going to get dissociated into ions, and that much only, yes, what you can relate, that much only you will be getting the ions accumulated. Like, it's very simple. If suppose you have, like, you must have seen that in the movies and all, no, like what they do, they give to a terrorist like that electric shock, or some person from whom they want to get the truth out, so they give the electric shock. So more electric shock, like suppose if you just touch it and come, are the person going to reveal the truth? No. So if more electric shocks you give, more truth they tell, right? Okay, this is there, that is there, that is there. So it's very simple. You can relate, more electricity you are going to pass, more electrolyte is going to dissociate it into ions, and more weight it is going to generate. It's very simple. So here what we can relate, that your W will be directly proportional to IT, that is current into time, but you won't be able to solve any stuff until you have introduced any constant. So what I'll do, so W is equal to, we introduce a constant which is Z into I into T. What we do, we introduce a constant which is Z, and what is Z, guys? Yes, it is equals to constant. What is Z? Z is equal to a constant which we use, and how you can define this constant, how you can define the Z. So it's nothing but, if, like you can relate, if you take I is equal to 1 ampere, means current you take 1 ampere and time you take 1 second. Yes, if you take current 1 ampere and time you take as 1 second, so what will happen? Your W will become equal to Z, no? Why? Because I you will keep 1 and 1, so W will become equal to Z. So what is Z, guys? Z is nothing but, it is the weight of any substance produced. So Z is a constant which is nothing but weight of any substance produced. So weight of any substance produced by passing 1 ampere current. 1 ampere current for 1 second. One second, and that's what we can understand, right? So what is Z, guys? Z is nothing but, it is weight of any substance produced by passing 1 ampere current for 1 second, and that is called as Z, or it is also called as equivalent constant. So constant, equivalent constant, or any way you can understand about it. Okay, so this is your Faraday's first law. Now let's just talk about the Faraday's second law, and the numericals related to both the laws we'll be doing in the next session, which is dedicated to electrolysis only. We'll be learning many other examples, and today we have understood the basics regarding electrolysis, electrolytic cell. That what is electrolytic cell? It is a device or apparatus in which electrolysis takes place. We also learned what is Faraday's first law, and now we are quickly learning about what is Faraday's second law. So Faraday gave one more law regarding the electrolysis, and what it said that, very simple, the amount of, what it said, the amount of different, yes, the amount of different substances liberated, the amount of different substances liberated, yes, the amount of different substances liberated by same quantity, by same quantity of electricity passing through what, guys? Passing through what? Passing through electrolytic solution. Electrolytic solution is directly, yes, is directly proportional to their equivalent weights. To their equivalent weights. Like how you can understand, it's very simple, right? Like suppose if you have same quantity of electricity, so you have copper dipped in a copper sulfate solution, and you have a zinc, say dipped in ZnSO4 solution. So what you did, you're taking copper dipped in copper sulfate solution, zinc dipped in zinc sulfate solution. So what you're doing, they both are different substances, but for both of them, what you're doing, you're passing the electricity like same. So you're passing 1 ampere current, right? 1 ampere current you are passing to both of them, or say you're passing 2 ampere current to both of them. So what they say is whether the substances are different, no problem, right? So what it says, they says the amount of different substances liberated by same quantity of current, right, by same quantity of electricity passing through electrolytic solution is directly proportional to equivalent weights. The equivalent weights, like how, what you can relate. So the weight of Cu generated will be directly proportional to equivalent weight of Cu. Yes, so weight will be directly proportional to this. Weight of zinc will be dependent upon the equivalent weight of zinc. Now what you can relate, both have the proportionality signs. When you'll be removing, you will get some constant, and when you'll be using that, so you can relate any of the two substances. You can compare weight of Cu divided by weight of Zn will be equal to equivalent weight of Cu divided by equivalent weight of Zn. Now in detail about it, that how we can utilize it. So basically what we understood a very simple thing, that Faraday's second law says that the amount of different substances liberated by a same quantity of electricity passing through a solution, electrolytic solution, is directly proportional to their equivalent weights. So that's what we have understood. And how you calculate the equivalent weight, guys? Remember? Yes, remember from basic concept. So equivalent weight, how you calculate it? It's nothing but it is equal to molar mass divided by, yes, it is equal to molar mass divided by n factor. And for here, the n factor will be equal to number of electrons involved. In detail about it, we'll be learning in the next session, guys. So what we have understood, let me just quickly tell. So today's class, we learned about what is electrolytic cell. It is a device in which electrolysis takes place. We understood what is electrolysis. It is the decomposition of yes, it is the decomposition of an electrolyte when the electricity is passed through its aqueous or molten state. That we understood. Then we understood the examples, that how we are going to get the different products on the basis of the different conditions. We also learned about the Faraday's law of electrolysis, that Faraday's first law and Faraday's second law. Very good, guys. Now let me give you little information about our classes, guys. But before that, I wanted to remind all of you, yes, regarding the offer which is extended. Yes, so there is an offer which is extended, and it is valid only till 29 July, guys. Today is already 26 July. So you have to make sure that you are taking a full benefit of this offer. So what you have to know, what prices you are getting over here. So if you will be taking the subscription till 29 July, the course, which is duration of 24 months, which you get around 33,000, you will be getting an offer around 28,000. So you can relate that you will be saving around 5,000 rupees, which is actually a really good saving. If you take a subscription for 18 months, so the price is actually the 26,450. So you'll be getting it in around 2,200, 483. So it is around 4,000 discount, like you'll be saving it. Same for 12 months and more month subscription if you take, yes, more savings you are going to do. So that's what you can relate. Yes, so for that, what you have to do, guys, you have to use my code, which is MRIS10, and you will be getting instant 20% discount. What you have to do, you have to use my code, which is MRIS10, and you will be getting instant 20% discount. Clear with it, everyone? Very good. So this is there. Along with that, let me tell you some of the information regarding the classes, right? So you should know that the prices, Unacademy plus subscription prices, are already very affordable. If you'll be using my code, which is MRIS10, I'm repeating it so that you'll be again getting the information that if you'll be using MRIS10, you'll be getting instant 20% discount. Now, what and all are the ongoing batches for the ISC Class 12, guys? So, Achievers batch is going on, which started on the 6th July. Yes, and we'll be having a coming batch for the August also. So, there also you can enroll for it. So, who and all are taking classes over there, guys? So, I'm taking the chemistry classes, and I take every Monday, Wednesday, Friday, 4 to 5 p.m. for class 12. And same way, we have a physics also, 5:15 to 6:15 for Monday, Wednesday, Friday, which like is taken by Mohana Thara ma'am. Biology is taken by Lakshya Gera sir, and maths is taken by Rahul Mohanani sir. Yes, guys. And the same way, you have a ISC Class 11 batch also, which has all the teachers same. And the batch which is going on is Brahmastra batch, started on July 6 only, and the same teachers are there who are doing the exhaustive coverage of syllabus. Now let me introduce you about our community, guys. So what is community? So you should know that community is a platform where we all can be interconnected always. Like how? So here, if you will be joining our community, so you will be never like you will never miss any update from your favorite educator. You'll be getting the session notes and practice material. You can share your feedback directly with the educators via polls. So that is there. Yes. So anyone is having any doubt, you can ask it. I'm so sorry, guys. So I was feeling to sneeze, and you can relate that it becomes very difficult to actually hold on that, right? So what I was telling, if anyone is having any doubts, Siddhartha, Veena, anyone, if you have any of the doubts, Harshit, you can let me know. Yes, everyone. Tell me, guys. So what you have to know, guys, you have to make sure that you are, yes, subscribing our channel, and you are, yes, you can download the PDF also by like subscribing our channel. And yes, it's very simple. You can download our app also, that is Unacademy app, and you'll be getting all the information out there. And today there is a special class, guys, in which we'll be learning geometrical isomerism. So all of you should make sure that you are joining that special class and learning that topic. Very good. So if anyone is having any doubt, you can ask. Otherwise, we'll be meeting in the next session. Thank you, all of you. Do subscribe the channel and press the bell icon so that you will be getting the notification regarding our upcoming classes. So okay, guys, we'll be meeting in the next session then. Thank you, all of you. Bye-bye. Thank you, guys. Bye, everyone. Bye, guys. Thank you.